Question is, how fast must a plane fly along the Earth's equator so that the sun stands still relative to the passengers? In which direction must the plane fly? East to west or west to east? Well, the sun sets in the west, rises in the east, so shouldn't you be going west?
Yeah.
Follow?
So it doesn't set? Yeah, you should be going west.
Yeah.
Yeah.
And then give your answer in both kilometers per hour and miles per hour. The Earth's radius is 6,400 kilometers.
6,400 kilometers. That's one that you don't need to remember, but it's always good to just know what the radius of the sun is, because you never know when somebody's gonna
Of the Earth.
ask you. Yeah, the radius of the Earth. Yeah.
I don't know, it might come on Jeopardy.
It might actually. What was it? I was listening to a talk show this morning,
Mm-hmm.
coming to school, and they're like asking random facts, like who's on the 50-cent piece, and there was like either Andrew or some guy Jackson or Bartholomew, whatever, a list of names. I'm like, oh, it's Jackson, and they didn't know it, and then they got it wrong.
You could have been the winner right there.
I could have. I'm like, oh man, I'm super sad. How do we do this one then, Chris?
Well, I was thinking first you gotta find the circumference.
Okay.
I think that would be good to know. So 2 pi r times the radius, right? Yeah. So that's 40,212.39.
That's not right. That's not. Still not good. Okay.
Now, I'm not sure if we're trying to find the velocity or omega or alpha. I'm not sure on that.
We're supposed to, what is the question? It says, how fast are you going?
Yeah, it says, how fast must a plane fly? So I'm guessing that's velocity.
Yeah.
To do so that the sun stands still relative to the passengers. So we don't really have a time, do we? Alright. Well, if the velocity is distance over time. I'm stuck.
Cool. First we have to think about what is happening.
Mm-hmm.
So we have our sunset. Let's say that this is us, right there. The Earth is going to be rotating. Like here's the, so it's going to be rotating like this way right there. So you're going to be coming up here. You're going to be right there in a couple seconds, right? Like on the surface. This is a sphere and it's rotating that way. So from here to here, in some time, you went some distance, some arc length. And we want to be able to keep up with the Earth so that we don't cover any ground over that same time. So really what we'll have to be going is, what we'll have to do is go the same speed as the Earth is rotating.
Okay.
And we know that in a day, for one full cycle, we can find out how fast the Earth is rotating. So we know how long it takes for it to go in one rotation, 24 hours.
24 hours. Times 60 times 60 per second. Right?
So that's your time. And then you have the circumference. Remember that velocity is equal to x over t.
Yeah.
So you just plug t in here and x into here, your circumference, and that will get you the whole thing.
Okay.
Thank you, pretty fancy.